Hi all, so as you know last week I got you to start looking at the next chapter, chapter 19, classifying materials. So you should have at this stage had a look through the first 10 slides and at this stage have a basic understanding of what matter is and what an atom is. So I'm just going to recap quickly on what you did last week and then move forward with this, okay? So firstly, you've revised what matter is. So matter, if you remember, is anything that occupies space and has mass. Your three main types are solid, liquid and gas, and then your fourth type is plasma. And the important thing to take from that is that matter is made up of those tiny particles. So in the same way as a human, as a living thing, we're made up of teeny tiny cells. All matter is made up on a chemical level of atoms, so tiny particles, whether it's water, whether it's the table, whether it's your pen, whether it's your laptop, they're all made up of multiple little atoms, okay? So an atom is the smallest part of an element that still retains the properties of that element. So all that means is if you look at gold, for example, if you look at a gold ring, the atoms, the individual particles in that are different from the atoms in, say, silver, or from, say, the atoms in helium gas or in oxygen gas. So depending on what the type of matter is, what the type of atom is, okay? So we can classify all matter then as whether it's either a pure substance or a mixture. Okay, pure substances are either elements or compounds, and we're going to look at what both of those are, whereas mixtures can depend on whether they're homogeneous or heterogeneous mixtures, and again we're going to look at what both of those are. Okay, so with a pure substance, first of all, we're dealing with where all the particles are the same. So if you look at gold, for example, gold, all of the particles in gold are going to look exactly the same. If you look at pure water, where there's nothing else added to the water, all the particles are the same. So they're examples of pure substances. If, say, you took water and you added salt, then there's two different types of substances there, so therefore that's classified as a mixture, okay? So with a mixture, you have two or more substances mingled together but not chemically combined. Okay, so as a general rule in mixture, they can be separated without kind of doing any sort of chemical reaction. So doing simple things like filtration. So if you have sand or mud and water, you can filter it, and that's an example of a mixture. So some examples of mixtures we have air, and the air that you breathe in, as you know, is made up of oxygen, it's made up of nitrogen, it's made up of carbon dioxide. So there's numerous different pure substances in there that when combined together make your mixture. Even something as simple in everyday life as pick and mix, you have a mixture of different types of sweets. Your ink in your pen, if you look at your blue pen, there's a number of different colours added together to get the blue ink. So they're all examples of mixtures which can be easily separated, and we're going to look later on at how we can actually do that in another chapter. So in terms of elements then, and this is kind of what I got you to look at the last day. So an element is a substance made up of only one type of atom. It cannot be split down into simpler chemical means, okay? So if you look, for example, at your gold ring, if you try and do chemical reactions on that to split it down further, you can't, because gold is an element. But if you look at something like water, you all are probably familiar with water being the symbol H2O. That means water is made up of hydrogen and oxygen. So by doing chemical reaction, you can actually divide water up into its basic elements. So the element is whereby all of the atoms are exactly the same. So if you look, as I said, at the likes of gold, copper, aluminium, iron, all of those, every single atom in there looks exactly the same. Whereas if you look at something like water, that's not an element. It's a combination of a number of elements. So when you look at them, the atoms, they're going to be different atoms in something like water. Okay? So all of your elements are arranged on your periodic table, which is available in your it's in your book, and it's also in your homework journal. So when you look at that, every periodic table is going to look the same, and they're all arranged very specifically, and they're all given specific numbers. We're going to touch on what those numbers mean in another chapter, but for now, all I want you to do is familiarize yourself with the letters and the symbols, okay? So I've asked you the last day to use this slide. Find the first 20 elements, and then elements number 26 to 30, 47, 79 and 80. And to use your periodic table, write down the symbol. So in this case, if you look at H is number 1. So what you should have written down is 1 equals H, which is hydrogen. And then to pick another one, if you look at, say, Ne there, number 10, so you'd write down Ne equals neon. Okay, just one thing to note on that, you need to learn your symbols. So you need to know Ne is neon, F is fluorine, C is carbon. Just one thing to note, any of the ones that have 2 letters, so if you look at helium, neon, argon, and beryllium, the first letter is a capital and the second letter is lowercase. So that's always the case. With your symbols, you always have a capital letter for the first letter, and if there's a second letter, you will have a lowercase. And there's just a couple that maybe seem a bit unusual. The likes of, some of them are predictable, but if you look at the likes of Na, sodium, okay, that's not one you can guess, so make sure you know those. And 2 that are very easy to mix up is silver, and gold. So gold is Au. There's no G in it, and Ag then is silver. So just be careful with ones like that you don't mix them up. Okay. So that's kind of where we left off the last day. So to move forward from then I have all of your symbols going down through here, the ones I asked you. So this is just to do a little spot check for yourselves down along. And there's a little quiz if you want to try and see, can you spell out the country from the different chemical symbols. I might get you to try that and send it on to me. I'll put it up on Schoology as an assignment. Okay. So moving on from that, so your elements, if you look at them, all elements are individual atoms. So your gold, it's like you with your cheek cell, you can take your individual cheek cells and look at them under the microscope. So the same would apply with atoms, in that you have individual atoms of gold, of silver, of hydrogen, and so on. Okay. When, however, you have a couple of those atoms stick together, that's what we call a molecule. Okay, so a molecule is formed from 2 or more atoms joined together chemically. Okay, and they're specifically chemically, which means there's a chemical reaction or bond holding them together to stop them from breaking free. So, for example, when you look at oxygen, you're all familiar with O2. Oxygen exists naturally in the form O2, so rather than just one atom being on its own, you always have 2 of them stuck together, so hence it's O2. Hydrogen, nitrogen, chlorine are the same, so there's just where you have 2 atoms of the same element stuck together. However, molecules can also have other elements stuck together. So if you look, for example, at one you're familiar with, CO2, you're all familiar with CO2, carbon dioxide. You have 1 atom of carbon stuck to 2 atoms of oxygen, and when you have multiple atoms stuck together like that, it's a molecule. So carbon dioxide and water is another one, H2O. You have 2 hydrogen atoms attached to 1 oxygen atom to make a molecule of water. Okay, so that's what a molecule is. Now, when you look at a molecule, the one that's easy to mix it up with is a compound. And a compound is a molecule that contains at least 2 different elements. Okay, so if we want to go back to the last slide there, you have a number of different molecules here. Okay, if you look at the first top one here, all of these are molecules, but they're not compounds. Okay, whereas the ones at the bottom, if you look, they have different types of elements together. So you have nitrogen and oxygen, you have hydrogen and oxygen, you have nitrogen and oxygen, and you have carbon and oxygen together. Those are all examples of compounds. Okay, so compounds have different elements attached. So all compounds are molecules, but not all molecules therefore are compounds. Okay, so to look at the examples here, again, you have water, you have hydrogen and oxygen attached together, so you have 2 different elements, therefore it's classified as a compound. Same with carbon and oxygen, same with CH4, which is methane, you have a carbon and a hydrogen. But if you look at O2, you only have oxygen molecules attached, so therefore it's a molecule, but it's not a compound. Okay. So hopefully that's clear for everyone from there. Yeah, so just to compare the difference between compounds then and elements. So when you look at an individual element, it has a specific set of properties, things that are relevant to it. So for example, carbon, the best example I can give you of carbon. Carbon is when your toast is burnt, the black stuff on your toast, so it's a black solid, okay? And oxygen, as you know, is necessary for burning. So if you have oxygen, you can have fire. If you combine carbon and oxygen, you get carbon dioxide. And carbon dioxide, as you know, is used in fire extinguishers. Carbon dioxide is a gas, so even though you have a black solid in carbon, when it's combined with oxygen, it becomes a gas. And carbon dioxide is used in fire extinguishers to put fires out. So while oxygen on its own puts fires out, starts fires, when it's combined with carbon, it puts them out. So when the chemical reaction happens to change them from individual elements into compounds, it changes the properties of that compound as well. So that's just an important little thing to note there as well. So you can have a look at those other examples there. So just to see what the individual elements that are like on their own, and then when you combine them as a compound, what the individual elements are like, or what the individual compounds are like separately. Okay, so what I'm going to ask you to do is look at this slide here. Again, I'm going to put it up as I'm going to put it up on Schoology as an option for an assignment, and I'm going to ask you to look at each of them and label them A, B, C, D down along, and tell me by looking at it whether it's an element or a compound. If you're struggling, look back on the notes, look back at the examples I've given you, and I'll put up the solutions later on. Okay. I'm also going to put this activity up for you as well, and this is where you have to match the element or compound with its use. So again, just to get you familiar with some of the more common elements and compounds and some of the things that we use them for on a daily basis. So what I'm going to ask you to do with this again is going to write out, well, with this actually, to make it easier for me to go through it, I'm going to ask you to write out, so A, chlorine equals, and then go down. So if you look, H here is done for you. So H is silver. So you can see H is number 2 and it's found in jewellery. So what I want you to write out is H equals 2 found in jewellery. Okay, and write it out for me. And again, I'm going to put that up as an assignment on Schoology for you to complete for me for next week. Okay, the last little bit I just want to look at with you today is mixtures. Okay, so we've looked at your pure substances, which is your elements, compounds, and molecules, and mixtures is the other type of substance that exists, and mixtures can be either homogeneous or heterogeneous. Homogeneous mixtures look the same. Okay, so if you look at your bottle of fizzy 7-Up or whatever you're drinking, whether it's orange, whatever it is, that looks the same all the way through. Okay, so that's classified as homogeneous. Okay, so you can see your lemonade there, it looks exactly the same all the way through. If you have a cup of coffee, a cup of tea, it looks exactly the same all the way through. So that's classified as a homogeneous mixture. Your heterogeneous mixtures, on the other hand, they look different. So if you look at your bag of pick and mix, you have all the different stuff going in through that. If you have a mixture of even something like clothes, you can see here, clothes on a rack, it's different. It looks different all the way along there. So that's classified as a heterogeneous mixture. Okay, so if it looks different as you go through it, it's heterogeneous. If it looks the same all the way through it, it's homogeneous. Okay. Yeah, so again, just to show you the difference here between a compound and a mixture. So the compounds would be where they're chemically attached to each other, where you have atoms chemically attached by a bond, the likes of your CO2, your carbon dioxide, your H2O, your water. Whereas a mixture is where you have multiple compounds or elements together. So you might have salt mixed in through water. That you can't see the salt, but it's mixed in, so you have the different elements and compounds mixed in through in your mixtures, and that's all that is. Okay, so this little table here, if you're still confused, helps to distinguish between compounds and mixtures. So your compounds are a single substance. So if you look at water, carbon dioxide, they are one substance. Whereas if you look at your mixtures, that might be salt water. So you have salt and water. It might be the air around you, which is carbon dioxide, oxygen, nitrogen, and so on. Okay. In compounds, the elements are always in a fixed ratio. So if you think CO2, you always have one carbon atom attached to 2 oxygen atoms. H2O is the same idea. With your mixtures, the amount of substances can vary. Okay, so I want you to have a look at that little table and learn it off. And again, I'm going to set a little activity on Schoology in relation to that. So that's as much as we're going to do today. I'm going to leave it at that. I'm going to upload this and a few assignments to Schoology, and you can keep on top of it for next week. Okay, thanks guys.